All right, I'll let everybody settle. So we'll be discussing React Native animations. This is a large topic, and I'll try to cram as much as I can into your heads in about an hour's time. Because it is so dense, if you do have a question, do feel free to interrupt me right there at that point, and we'll cover it. But we'll also be taking questions at the end if you prefer to keep them till that time. And so, like she said, my name is Bertrand, and I work here at Rangle. So let's take a look at animations in React Native. Before we go ahead and dive right into it, I wanted to stress this point. They make this point a lot, the React core team, and I think that's the point that most people do believe in. Fluid, meaningful animations are essential to the mobile experience, especially if you're in a consumer space. So they have spent a lot of time thinking about how to do this, and so has the community, and I'll try to impart kind of that thinking to you guys. We'll talk about a few APIs. React Native by default ships with 2 APIs that you can use. One is called layout animation, and the other one is simply called animated. You'll hear a reference as the animated API. Layout animation is what it sounds like. It handles global layout transactions. And what I mean by transaction is that within your layout, whenever something animates, some other part of your layout needs to respond to it. So it allows you to go ahead and declare those relationships. Animated, on the other hand, is much more granular. It doesn't concern itself in terms of its abstraction with the layout. It concerns itself with almost anything that you can think of that you want to animate. And so we'll go ahead and do a deep dive into layout animation. That probably solves about 80% of any kind of requirements you may have in your application. And then we'll go through animated as much as we can because it is very powerful and very large. So let's talk about layout animation first, and let's go ahead and do a deep dive. This is a very great abstraction for handling what are typically just layout user UI-based or UX-based type animations. So what is layout animation? So like I said, it allows you to globally configure, create layouts. So the 2 parts that it concerns itself with is create and update. Create, so the creation of that view component, and whenever it updates. So it takes care of animating the creation and the update part for the next render cycle. So in a case, we'll see this soon. Who here is not familiar with React? Okay, everybody, great. So the next render layout cycle typically occurs when state has changed, and we'll see that in a bit. So layout animation will allow us to do things like flexbox layout updates without having to go ahead and grab each and every single view, getting their measurement, and changing each of their measurements in kind of manual synchrony, right? And it also allows to do a very cool thing, which is allows elements to also affect their ancestors. So what I mean by that is that, let's say you're a child, your animation and your update can affect your parent, but also any of its siblings. And so that's a very hard thing if you can imagine trying to do all those, grabbing all those references and trying to update them all manually and in lockstep. So layout animation gives you a declarative, as much as possible, interface to doing this kind of work. So let's kind of look at how it works. It essentially automatically animates. This is key. This is it takes away the manual aspect of this whole thing. Views to their new position when the next layout is about to happen. Think of a list layout where you want a list to expand, for instance. That kind of work. So typically, the workflow is simple. You configure the next transition, and then you trigger the next state by using setState. That's, broadly speaking, the abstraction here. We'll look into just how powerful this is actually quite simplistic. We'll look into just how powerful it is. But before we do get into layout animation, let's talk about springs, because I think springs are awesome. So this is what a spring animation would look like in layout animation. So you'd go ahead and configure a duration. And here you'll notice, like I said, create and update. We've added delete as well. So this is the entire life cycle of the view as the state changes. So in this case of create, we're saying, you know what? We're going to just have an animation of type linear. These are all keywords. and it's going to operate on the opacity property. So it's going to go from 0 to 100 in create linearly. That's all that said, without you manually doing it in code as this.state changes. During update, we're going to say, hey, we're going to declare the animation to be a spring animation, and then we're going to declare a spring damping, which is really what we're talking about when we talk about spring damping. It's a combination of the friction and the spring constant in the spring. So just how firm it is. Delete here, again, we're just going to say we're going to, as it gets removed from the view, we're just going to linearly toggle its opacity. That makes sense? OK, great. So how do we use this configuration? Like I said, configure next. So you pass this on to the layout animation, which you can just grab and import from React, and just say, hey, here's the configuration. This is how I want you to animate this view whenever the next layout occurs. You'll notice that there's a optional second parameter. This you can put a callback here to be called when that actual animation ends. A common use case for this is cleaning up resources. Just be aware that if you're writing cross-platform React Native applications, on animated did end is currently only supported on iOS. There's currently work right now ongoing to bring it into Android. It was there at a certain time, but it got pulled back, so it's not public yet. So just be aware. There are other, but if we go back here a little, this is a little bit of a lot of work, and we needed to do all this work because springs are not simple. A lot of the animations you may be interested in doing are fairly simple, and so layout animation actually provides you a nice helper called create. And this is how you would use create. Create takes a duration, a type, again, that string constant of the animation type, and a creation property. So what property do you want to change based upon create and delete? And so here for a linear one, we'd just pass in 500 here, 500 milliseconds, linear update, and opacity on create and delete. So it would essentially do what we did before, but just a much simpler version, obviously. The same thing with easing in and easing out, because that's also available as a keyword. This is so common, linear ease in and ease out, especially because the platforms themselves have already UI conventions around these transitions. They have specific timings. And so the team went ahead and gave you presets. So the ease in, ease out is Apple's ease in and ease out, or very close approximation of it. And you have the linear is linear, and you have the spring and spring. These are just defaults. You'll see them almost everywhere. You don't have to think about how many milliseconds does your view need to animate linearly for it to feel right, and not too quick and not too slow. So we'll get to an example in about 2 seconds. You'll notice I'll just use spring here. I won't go ahead through the trouble of recreating that thing. But it's not doing anything that you can't do yourself by just specifying this configuration map with a duration, create, update, delete, and passing it to configure next. It's essentially calling configure next with that object and not doing anything more clever. So this is I like this animation. It's in some of you who have looked at the React Native documentation may have seen it. I just want to point out a few things here. There's a box and a button underneath. And as the button is pressed, 2 things are happening. The box dimensions are changing, and the button's place with relative to the button is also animating in response. It's not just snapping to that location. Some of you can guess what animation is ongoing right here. In terms of linear ease in and ease out, this is spring. And so we'll look into how you would build this. And everything is just an extension of that methodology. So let's take a look. Everybody here is familiar with React components, but here's the shell, right? Here's a class app. This is whatever your component name. It's a sending React component. For this exact example, we're going to talk about, we're going to fill in with a few methods here. If everybody can see, the constructor is just the method used to initialize the component. The component will mount occurs right before the component is placed onto the view. So right when it's about to be mounted onto the view, we're going to do some setup. OnPress is the event that you guys saw witness when we press a button, and render is the typical React render method. I'm going to show you where I'm at. And so let's go ahead and fill these in and show how layout animation kind of allows you to build this. So in constructor, we're just going to call super, because we have to. We're going to set state, that we're going to track our component's current width and height, and we're going to start at 100. Everybody good? And then we're just going to bind the onPress to this. If you've done React before, this is just the first line and the last line are just boilerplate. What I want you to focus on is that we're setting the initial state to a height of 100 and a width of 100. In component will mount, right before we're about to mount that component, we're just going to say, hey, layout animation dot spring. What it's doing underneath is it's running, again, the create. It's running this, not create, sorry, configure next. So it's running this guy, configure next with a spring config, the one that's built in, which might as well be this one. So like I said, layout animation is two things. You call configure next, and you change the state, creating the next render cycle. And so in our case, when we do component will mount, we just do the first part. We're going to configure ourselves. So this is what's going to happen next whenever the state changes. Is that clear? Yeah, pretty easy. On press, we're going to go ahead and configure layout animation.spring. So in this case, if you're wondering, in this case, layout.animation.spring does the same thing. Be aware that you can change which one you want if you wanted to, right? You don't need to set a single animation and be stuck with it. You're always configuring the next. So if you wanted to, you could go ahead and just decide to be linear when it's an odd number or something, where it's an odd. So in this case, we're just declaring it again before we change the state. In this case, we're just incrementing the height and the width by 15 at every single interval when the button's pressed. Is that clear? This is just what's going to be fired when the button's pressed. And so this is the view. It's a little small, but a few things of interest is that we have a view here that's our box, and it has a width that we have set on the state and a height that we have set on the state. And then we also have a button here, which is just a touchable opacity, if you guys are familiar, that just binds to this onPress. So we just went ahead and you'll see that they're essentially, in this case, siblings. That's it. So buttons here, the box is here, the button's here. We're binding the action to the button, and the box is just being styled with those properties that we're animating and changing. And so that's it. That's all you have to do this. Whenever you press me, we configure next with whatever kind of animation sequence we want, and we set the new values. In this case, we're just going up by 15 at every single press. Does that make sense? So that's layout animation. For a lot of the use cases that you have, especially when you're making components, what this allows you to do is essentially build components and really keep the concerns of how these components animate within that component itself. You'll notice here that we could have went and had other elements on the other page animate differently within their construct, and we wouldn't need it to care, so long as they don't conflict and look weird. But so a few caveats. Like I said, Android support for, like I said, the callback is not yet in Android, and this mechanism is still experimental in Android support. But it's been very stable for a very long time. It's just you have to enable it. It's not there by default into the view. So here, if you're an Android, go ahead and make sure that that method is on the UI manager, and go ahead and call it true. I don't believe that method is on the UI manager if you're within an iOS context. It wasn't before. So it's very powerful, but it provides less control. So that's what we traded. It's very declarative, and it's very easy to implement. And we basically covered all that we needed to cover of its API. But yeah, the concern that we do have is that it is it is very much less concerned with giving you full control over how things move in the minute. If you want to do that, if you really want to control exactly how it's animated, um, they provide it. There's a library called Animated. And let's take a look at how that looks. So we'll do a quick look, which is actually a very long quick look, but we'll scratch the surface of it. So this allows you. This is again. This follows the React kind of philosophy again, as declarative as possible. But in this case, we just want to. The library authors wanted to give you control over very explicitly and very expressly on almost all the different properties you can control, all the different ways that your views can change and move, and do so in a very performant way. So what they've done here is, you'll notice that when we set the Spring constant, we didn't really set all that much. We didn't really define all that much. In this case, we defined a constant, and the rest was taken care of for us. We'll look at another Spring very soon, where we declare much more than that. But the nice bit about this and the React philosophy is that because it is declarative, they get to optimize the performance for you without you changing your code. This has been getting faster after every release. In fact, I think it was release 27 or 28 when the core Facebook team had to implement, I can't remember, something in the Facebook.com app, and they just went ahead and profiled it and brought in all these performance optimization that met the needs of Facebook.com, and the community just got to benefit it, just naturally. Everybody's app just got faster because they updated a version, because the Facebook.com team really needed to meet the standards of that application, which is all native. And so this is a very big reason as well why to use this framework. It is more complicated, but only slightly so. We define, like I said, a declarative relationship. So we want to get out of the imperative animation, like what we've seen before in terms of the prior art, where you yourself are in charge of getting your current dimensions and moving them. So the idea here is you have an input, which is some kind of value, and then it's going to be configured to output a new value, and in between those two values, it's going to be transformed in some way. So that's the way that you typically will think of animated configurations. In the case of the Spring, we went from maybe a width of 10 to a width of 25, maybe a bad example, 100 to 115, and it took that constant and it mapped every single unit between those two values. That's that constant that we were specifying. In this case, we're going to tell it exactly how we want it to map. The second thing is we get to tell it when to start and stop. So if we wanted to do bounce, and maybe we wanted to do a flash, and then we wanted to do a pop-in, being able to go ahead and declare how those happen, in what order they happen, and when one starts and when one goes into the other. They could overlap. They can maybe just start and stop exactly at the boundaries. So this is very much more powerful, and we'll look at a simple example, but and we'll go through as much as we can, actually. So let me try this. There's a video here. So I just have a different image that I'm bouncing. So it's not very different from what we saw before, but in terms of the implementation, you'll see that it's a lot more expressive. So this is our new app. It does the bounce again. It has a constructor. We'll use component did mount now. So component will mount is before it's rendered into the view. Did mount is when it has been rendered into the view. And render, again, every component has a render. The super is boilerplate. Here we're setting state. And I'll explain what animated.value is. It's just a singular value. So we're just going to box it because we're going to want to do stuff on it. And so we set a bounce value and it starts at 0. That's it. Can everybody see that? So here what we're doing is we're taking that bounce value when the component is on the page, and we're setting it to 1.5 in this case. As you can read in the comment, we're just making it larger. It started at 0. We're making it 1.5. And then we're grabbing animated here instead of layout animation, and we're calling Spring again. So far, you've seen this before. Where it gets interesting is in the definition of it. In the definition of it, we're going to pass it the value, this boxed thing that we care about, rendering. And we're going to pass it a configuration. In the case of the Spring, there are two configurations that Animated has provided for you. A to value, so what are you animating it to? In this case, we're saying we're going from 1.5 all the way to 0.8. In this case, it's static, as you saw in my demo. This could be anything. This could be your current finger movements. If you want to do something like chat heads, this could be dynamic, is what I'm trying to say, and it could track that. And the friction, this is just a Spring friction. So a friction of 1 basically means it's super bouncy, and we can make it a little more thirst. And then notice here, we're calling start. So that's what we've done. When the component did render, we just told, hey, animated, watch this value, set it to this number, and you know what? Animate it using this configuration now. That's it. So whenever this thing is mounted, it's going to bounce. Looking at the render, there's a few things that we'll, again, dive into, but you'll notice that we're not using an image or a view. We have here animated.image. So we're using views that Animated provides. It'll provide an animated, and we'll go into some of these, but in this case, this is the exact same interface as the React Native image. It's just you're now using that exact image. This is an image that's aware of the animation framework. What's interesting here is that in styles, under transform, there's an array. It's an ordered array of animations that you want to attach to this component. So in this case, we mapped scale. So that's the scale of that image to bounce value. And that's all we did. Notice there's no set state. We just told React that when the component mounts, I want a Spring animation. This is the value that I want you to Springify. So mapping the input of this value from I think the original 0 to 1.5 to 0.8, and just do it when you start. And in this case, we're saying, hey, animated image, here's a transformation, map your scale to that bounce value. We're never doing this.setState. This declarative nature is why it allows the developers to go back later on, perform any optimizations they want underneath the hood of these animated views without you having to change your code. So it's very declarative, and also it happens to be very performant. You can try to do this using animation layout and doing set state. It'll be noticeably slower. This is really fast. I can underscore that aspect of the animated API. So if you go back to this video here, let me run it. OK, sorry. It mounts, it bounces. You're not in charge of taking the scale values and tracking them and expanding them and retracting them, which is great. But you're also not in charge of setting state, which means that it gets itself smartly knows when to render. It has control of that lifecycle. You just tell it, I want you to bind this value to this transformation on the styles. But it allows for much more. So let's take a look at that gigantic API. We won't be able to use examples for every single one of these, but if you have a question or you have like something in mind, just please shout it out. Like I said, remember when we said in the constructor there are values? There happens to be two values. You saw value, which was just a single value. There's also value xy, which allows you to have 2D coordinates and animate in an x and y. So animate a vector. They're the same interface. You'd go ahead and grab it, set value the same way, except you'd have to set an x and y in that case. We saw Spring. There are a few other animation types. There's decay and timing. Spring is a Spring physics model. The model exactly that they're tracking is it's one that they released in a design tool called Origami. And I think Bounce.js uses the same one. If you've ever used Bounce.js, The nice bit about this is if you guys have a UI, UX team, is that they can go ahead and prototype these things, not in code because that's expensive and it takes forever, but prototype these things in Origami, which is Quartz Composer, but with a layer on top, and go ahead and do that in there, and essentially export those configurations. They could actually send you the code that they want you to, the animation, so you don't have to eyeball it, or I don't know what else you have to do. There's also decay and timing. Decay, you have a velocity, and it comes to a stop. It's a decay. It's, again, when we're dealing with this, remember that we're going from an input to an output. All these are a question of going from an input to an output. In the first case, we're going from a number to another number using a spring. So it kind of bounces. So it can overshoot that number, for example, because it's a spring. In case of decay, it's just you're gonna give it a velocity that's required, and then you could give it a deceleration rate. So the rate at which that velocity decays, it has a default. It's about 0.997. So it decays very slowly. So it has a smooth decaying gradual thing. Timing is a simple map of time ranges to easing values. The cool thing about this is that this is basically, when you change your views, if you're using one of the React Native animation, this is what it's using underneath to go ahead and swipe the old view out of view and bring the new one in. This is very complicated in terms of what it takes in, but it also allows you to define any arbitrary curve. So here we're talking about setting up a mapping that defines an easing curve. So easing is out goes like this, but you could have any curve that you want. It could go up and come back down. So those are the animation types that are built in. We saw animated.image. So in order to do that, in order to have all this work, including setting that bounce value and not having to set this.state at every single point, you need to use animated aware components. It ships with about 3, view, image, and text. The nice thing about it is that you can go ahead and create your own by just wrapping it and create an animated component. Every single ones that I've tried so far have actually just worked out of the box. A very cool thing is, if you guys are familiar with the React Art project, which provides a bunch of different shapes, you can just go ahead and throw those in and animate those shapes however you want. So just make sure, again, like we saw that you're using an animated aware view. This just gives you the ability of mapping to that bounce value without setting state constantly. OK, so this is where the power really starts shining. Sometimes, we went ahead and just called start on an animation. But what if we wanted more things to occur than just that? So animation allows you to declare sequences, which are an array of animations. And you can go ahead and make them parallel sequence, meaning one starts, finishes, start, finish. They're serial sequential. Stagger, meaning that you get to configure how they're overlapping. So I could be bouncing while I'm fading, rather than bounce and then fade. And then delay, the same thing. We have that deterioration. And you can mix and match them. This is going to be very small. But if everybody can see this, on animated, we just call sequence, and we pass it in an array. And in this case, we're passing in here a decay with tracking an x and y of a gesture. And here, in parallel, we have a spring animation. And then, in parallel with that spring animation, we have a timing that does a twirl, which is a constant of one of those curves that are included for you. And then we call it with start. Same idea, just a lot more power and a lot more control. Again, you'll notice that you're not doing these manually yourself. You're going to bind these through animated. So input to output, we're really talking about interpolating a lot of times when we're dealing with animations. So React Animated provides an interpolate utility for you to use to create your own animations. In this case, it's it's a mapping. Here I'm saying when it's 0, I want the output to be 0. When it's 1, I want the output to be 100. When it's 5, can anybody guess what it's going to be? It's going to be 50. It's just going to go ahead and interpolate these. So, but that's a very simple example and not very fun. You could have done this with linear. This is a lot more complicated. Here we're saying, if it's in the minus 300 range, map it to 300. If it's minus 100, map it to 0. If it's at 0, map it to 1. If it's at 100, map it to 0. If it's at 1, map it to 0, and on. So this is a new interpolation curve that we created. And so you'll see here that when we start at minus 400, it maps it to 400. It maps it along that interpolation up above 300. Those are just points along that curve that you're setting in that interpolation map. And so we keep going down, and we get closer to 0. Then when we're at negative 100, we're exactly at 0. When we're at negative 50, we're at 0.5. We're following? And then when we go past 50, when we get to 100, we're at 0. When we get to 101, we'll stay at 0. When we go to 200, we'll be at 0. When we go to 300, we'll be at 0. We'll be at 0 forever, unless we add an entry at the end. It's using this a lot for the ones that are built in, but you can make your own curves. So this helps really much with, so you can imagine any sort of transition of a view or any property of that transition. So it's not just that we're moving the x and y of the view. Its size is a property that we can track in this manner. Its width, its any kind of visual property of it. Opacity is one other that you saw. This is another use case. You may want to spy on that value. Spying meaning you may want to know what that value is. So far, we went ahead and called start and component did mount. We said, hey, we want our scale to be tied to this value. But we have no idea what it is because we're not doing set state manually. But it might be useful to know for different reasons what that value is during the animations or after. There's a few ways, there's a few things that animated gives you. There's animated.event. Any gesture in the React ecosystem has a certain shape. Like if you've ever looked at a touch, it has an X, it has a Y, it has a direction, it has all these other properties. What animated event allows you to do is map those values, those touch values, to events that animated can use as an XY value, for example. So those bounded values that it uses. So if you remember, we only have two value types that it's aware of. So what animations.events allows us to do is map common native, e dot what have you, x to that. So it can turn a touch gesture into a value underneath that can be animated and tracked and all that stuff. If you have an animated value, whether it's value or value xy, you can call stop animation on it. This just stops it, and it gives you a callback. That's going to be called when it's actually stopped. So the common case here is gesture transitions. I did a circle, and now my settings should pop up. Or I moved, whatever you can imagine, really. Upon that animated value, you can also add an event listener. That's probably the clearest, easiest thing to understand. If you take some value, like bounce value, add event listener, and you pass a callback, whenever that value changes, your callback gets called. Do not do anything expensive in that, for obvious reasons. It gets called a lot, depending on your animations. A lot of people go ahead and bounce whatever expensive action they have in there. Whenever you need a recent value for whatever reasons. So a common case for this is maybe somebody is doing a peek of the next view. And so being able to track that to know just how much to show maybe, because you don't want to render the rest. Whatever you want, these are kind of the hooks into it. So you can start to understand how just massively expressive this all is. You probably don't want to start here for obvious reasons because you're going to be working a lot. Layout animation will solve many of your core. In fact, if you're using the built-in navigation components that React Native provides, they're using animated in the background for you. So that's fine. And then you can add your own, start with layout animation, and use this when you really want to do something that's very powerful and that needs to be very performant. The cool thing about animated, before we move on, is that It's currently, I've been talking about it in the React animated context. It's currently being moved to React proper as well. So every single thing that you saw here and sometime in the future should work for React. Actually, it does already, but it's very beta. So you can go ahead and look for React animated, and it's there. Everybody's good? Great. That was very fast. So you guys get a bonus. So React Native gives you animated. It gives you layout animation, and those are great. They're new to a large degree as well. And in the community, kind of took up the slack in the earlier days. And the shining example of this has been the React Motion library. It's worth knowing too, because it's a very good tool in your arsenal. It does some things that layout animation does. It does some things that animated does. But I think they're moving currently to using those two underneath. Really what it provides you is the ability to talk about, it provides another abstraction. The ability to talk about views that maybe don't exist anymore in the future. So here's a few things that you may want to, if you're having trouble using animated and layout animation, there's a lot of prior art. You can see plenty of examples of doing these, but these are some things where React Motion built upon the interpolation, the springs, and all the stuff that we've seen, that it built for itself. It's right now moving to using the ones that React Native is promoting. But so chaining the items with many others. So this is a question of staggering. We saw how we could do that with animated, but how would you stagger a bunch of views, for example? You probably have to back them all with animated and do it yourself. It provides essentially like a layout animation type abstraction, so a very higher level abstraction for doing staggered views. So that's doing animation before unmounting. So these are life cycles. So we looked at one way of doing that with the delete and layout animation. This just allows you to do that as well. So it's not either or. There's a lot of things that these have in common because they kind of developed independently. Animating the child through layers of abstraction. Again, this parent-child relationship, this tree relationship, where things along the tree can move, and it renders that as you would expect, without you having to know what the child that's 3 levels down and 4 levels deep is doing. Animating across views. This is the hardest thing to do manually. I have a view that's being destroyed, but it's reappearing on the next view. So I want to declare, let's say I was going from one view to the other, and I wanted my profile to move from the left to the right and pop up into the middle, into my profile view. So this component is being, as part of this view, is being unmounted, supposedly. It's not really, but in the React abstraction, it'd be unmounted and then be recreated on this other view. So how do you go about declaring that cross-view type relationship? So in those cases, React Motion brings you very nice APIs to be able to control that. And the APIs are probably not the best reasons for React Motion. They're great, but the example in the prior art that exists out there is just astounding. A lot of people so basically, if you want to do a Twitter heart, the Twitter type kind of heart animation, Periscope, sorry, type heart animation, you can go ahead and look at a RN play example. There's probably an example for almost everything that I could think of. The community around React Motion is just, it's really nice. It's been growing for a long time. Animated, again, like I said, it's new, and even on Android, you saw we had to flag the experimental curve. This has the benefit of having been around for a bit. So it is worth considering in whole. So this is the API. This is a self-level API. It provides a string, because strings are useful. Almost everything is a string. But it also provides motion, stagger motion, transition motion, and a set of presets. And those 3 in the middle are what I was discussing when I was talking about these use cases. They attack these use cases, including item cross view. Yeah, that's it. Thank you.